All right, so this is a recap of ions, which is ASPT 3.1. So just remember, when we're talking about the difference between atoms and ions are what we see on the periodic table. We assume that every element on the periodic table is representing the neutral atom of that element. Therefore, the protons and electrons are the same, and that's what makes a neutral atom, because the protons have a positive charge and they need to cancel out the electrons, which have a negative charge, to give us an overall charge of 0. So I'm going to go through the examples kind of like you saw before. I'm just going to go quickly through them, just talk about it. So remember, an atom's life goal is to have a full outer shell, and it is going to do that because it's preparing to bond with other things. And we haven't got to that point yet, so we're just trying to make ions right now. So if you look at fluorine, which is on your left, the Bohr model of it, it hasn't met its life goal because it only has 7 valence electrons, which are there's 7 outer electrons in its outer shell. So the thing that it's going to do is it's going to try to get to that outer shell as quick as possible. In order to do that, it only needs to add 1 outer electron to get to 8. So if you look over here, the outer electron that it added is in yellow. It only needed to add 1 because it was really close to that. So the other option, the other alternative would be to lose 7. Well, that doesn't happen because just like teenagers, atoms are really lazy. They want to do the easiest thing possible. So they're going to go to it's just like rounding. They're going to go to the quickest way. So adding 1 is a lot easier and faster than taking away 7. Okay, so other things that you need to know are the ionic symbol. You need to be able to write ionic symbol. So that is the symbol of the element plus the charge. And if it's 1, it's implied, so you don't have to, like we see F minus here. But if it was anything bigger than 1, like F minus 2 or something like that, you would need that. And this is an anion because it is a negative ion. One way to remember that is a negative ion, or people think it looks like the word onions, which has a negative connotation because they're smelly, that kind of stuff, whatever works for you. Okay, another one would be boron. So if you look at boron here, again, hasn't met its life goal. It doesn't have a full outer shell. So what we have to do then is we have to either add 5 or lose 3. Well, again, they want to do the quickest way possible to do that, and that's losing 3. So if it loses 3, we have then taken those away. So if I draw an ion of boron, it actually only has 2 electrons versus what it had before. So my charge would be B plus 3. That's my ionic symbol. And how I got positive 3, 2 ways. Either you're talking about taking away 3 negative parts, so you're taking away negativity, which makes it positive 3, or if you look at the difference between protons, which is 5, and electrons, which is 2, so positive 5 to negative 2, which would give you a positive 3 charge. And this is a cation. Other ways to remember cations are always positive. Cats have paws, and cations are positive. Or there's a T in cations, which looks like a plus sign. Okay, 2 different ways. Now, mostly all elements can only make one type of ion. However, group 14, which is in the carbon family, they actually can go both ways. Because if you look here, the max is 8. So I either can take 4 away or add 4. So what we have is we actually have 2 ions of carbon, and those are 2 possibilities. And silicon, germanium, everything in that same group, that same family, is going to behave in that similar fashion. Okay, so because 4 is right in the middle of 0 and 8. Okay, so those are special because they can make both of them. The last thing before we go to the recap, there is a group 18, that has already met their life goal. So this is where we're talking about helium, neon, krypton. All of those have met their life goal. Those guys are never going to become ions. And the reason why, they're not going to gain or lose electrons. They call them the noble gases because they don't bond with anything and they don't react. And the reason why they don't is because they don't change their electrons. Okay, so everything can only make one type of ion. There are the group 14 actually can make both cations and anions, and group 18 will not make ions. So, the recap. An ion is when the protons do not equal the electrons, and the electrons have a full outer shell, however that looks. And if an atom gains electrons, it's going to be negatively charged. It's called an anion. Remember, a negative ion, or it looks like onion. Atom loses electrons, it's positively charged, and that's called a cation, because cats have paws, or cations have a T in them, which is then negative. So let me know if you have any questions, but that's pretty much 3.1 in a nutshell. You will need to be able to draw both of those, because I think that's the easiest part of how to change it from an atom to an ion, is drawing the atom, then switching it to an ion. Let me know if you have any questions. Good luck.